Good day, everyone. Before we start, let me first introduce myself. I am Marichel Dihito, and today we will be discussing different types of weather instruments and their uses. Meteorologists use a wide variety of different instruments to measure weather conditions, but many of these instruments fall into relatively common overarching categories. Thermometers, for instance, come in traditional liquid in glass forms and newer electronic forms, but both measure temperature in Celsius and Fahrenheit. Other instruments measure aspects of weather like rainfall, pressure, humidity, and wind speed. These instruments and measurements allow meteorologists to make predictions on weather conditions in the near future. Before we start, I have here a set of jumbled letters and other activities. First is, can you guess what kind of weather instrument is this? Just comment down below your answer and your group number. The first group who got the correct answer will be having 1 point in each correct answers. Good luck! Very good, you get the correct answer. Now, let me discuss what exactly is rain gauge. A rain gauge, also known as an odometer, pluviometer, or an ombrometer, is an instrument used by meteorologists and hydrologists to gather and measure the amount of liquid precipitation over an area in a predefined period of time. A rain gauge is a simple instrument anyone can install and use. Basically, it looks like a transparent cylinder with markings. You can read the amount of rainfall in inches or millimeters. Yes, it's only a simple instrument, but it gives powerful information that you can use to make better decisions. Another round for another set of wind instrument. Again, comment down below your answers with your group number. Good luck! Yes, you're right. This weather instrument is called barometer. A barometer is a scientific instrument used to measure atmospheric pressure, also called barometric pressure. We all know that the atmosphere is the layers of air wrapped around the earth. That air has a weight and presses against everything it touches as gravity pulls it to earth. Barometers measure this pressure. Atmospheric pressure is an indicator of weather. Changes in the atmosphere, including changes in air pressure, affect the weather. Meteorologists use barometers to predict short-term changes in the weather. A rapid drop in atmospheric pressure means that a low-pressure system is arriving. Low pressure means that there isn't enough force or pressure to push clouds or storms away. Low pressure systems are associated with cloudy, rainy, or windy weather. A rapid increase in atmospheric pressure pushes the cloudy and rainy weather out, clearing the skies and bringing in cool, dry air. I have another set of wind instrument to guess. For those groups who still doesn't have a score, keep on going. You're right, this weather instrument is called hygrometer. A hygrometer is a weather instrument used to measure the amount of humidity in the atmosphere. There are two main types of hygrometers. a dry and wet bulb psychrometer, and a mechanical hygrometer. Wet and dry bulb psychrometers are the most simple and common way of measuring humidity. This type of hygrometer uses two basic mercury thermometers, one with a wet bulb and one with a dry bulb. Evaporation from the water on the wet bulb causes its temperature reading to drop, causing it to show a lower temperature than the dry bulb. Relative humidity is calculated by comparing the readings using a calculation table that compares the ambient temperature, the temperature given by the dry bulb, to the difference in temperatures between the two thermometers. Lastly, brace yourselves for the another set of guessing game. Good luck! Yes, you're right. This type of weather instrument is called snow gauge. A snow gauge is a tool that hydrologists and meteorologists use to measure the amount of snow or solid precipitation that falls over a specific amount of time. The snow gauge is a derivative of the rain gauge, which was invented in 1441 during the Joseon dynasty and called the chugogi. The simplest design of a snow gauge is made up of a catchment container and a funnel-shaped gauge which are mounted on a pipe outside. Once the snow has been collected, it is removed from the pipe and melted and measured in a graduate container. The amount of water is usually multiplied by 10 to determine snow depth. Because of the variance in the water content of snow, the multiplying factor can vary greatly from 5 to as high as 30. Snow gauges are only able to provide rough estimates of snowfall for this reason. In continuation of our discussion, Fatima Lozano will also discuss another kinds of weather instruments.
The answer is thermometer. Now, let's talk about what is thermometer. A thermometer measures the air temperature. Most thermometers are closed glass tubes containing liquid such as alcohol or mercury. When air around the tubes hit the liquid expands and moves up the tube. A scale then shows what is the actual temperature is. A thermometer has two important elements. First, a temperature sensor in which some change occurs with a change in temperature. And second, some means of converting this change into a numerical value. Thermometers are widely used in technology and industry to monitor processes in meteorology, in medicine, and in scientific research. If your answer is wind vane, you're correct. Now, let's talk about what is wind vane. A wind vane is an instrument that determines the direction from which the wind is blowing. While many weather temperature can be somewhat complex in design, wind vanes are typically quite simple. In most cases, a vane will sit on top or hang below a spindle, which allows the vane to rotate on a horizontal plane. Like anemometers, situating the wind vane on a horizontal plane allows it to measure activity regardless of wind direction. The vane itself will generally feature a point on one end and a long and bored shape at the other. This will ensure the vane always points in the direction the wind is originating from. The answer is anemometer. Now, let's discuss about what is anemometer. An anemometer measures wind speed. The cups catch the wind, turning a dial attached to the instrument. The dial shows the wind speed. Anemometers are important tools for meteorologists who study weather patterns. They are also important to the work of physicists who study the way of air moves. The most common types of anemometer has three or four cups attached to our horizontal arms. The arms are attached to a vertical rod. As the wind blows, the cups rotate, making a rod spin. The stronger the wind blows, the faster the rod spins. The anemometer counts the number of rotations or turns, which is used to calculate wind speed. Because wind speeds are not consistent, there are cuts and lulls. Wind speed usually average over a short period of time. The answer is psychrometer. Now, let's discuss about what is psychrometer. A psychrometer measures humidity by taking both a wet bulb and a dry bulb temperature reading. A psychrometer is an old-fashioned type of hygrometer, which is a device for measuring humidity. It consists of two thermometer bulbs, a wet bulb and a dry bulb. The dry bulb measures the ambient air temperature in the same manner as any household thermometer. The wet bulb is covered with a cloth, usually cotton, that needs to be moistened with water before use. Once a wet bulb is ready, the scientist either swings the psychrometer or lets it stay still, depending on the design of the device, until the wet bulb has cooled to its final temperature. Then, by knowing the difference between the wet and dry temperature and the atmospheric pressure in his location, he or she can determine the humidity of the air.
Weather map. It indicates the atmospheric conditions above a large portion of the Earth's surface. Meteorologists use weather maps to forecast the weather, and it is also known as a synoptic weather chart. Displays various meteorological features across a particular area at a particular point in time, and has various symbols which all have specific meanings. Standard symbols on weather maps shows areas of high and low pressure, fronts, types of precipitation, and temperatures of major cities. Windsock. It is a conical textile tube that resembles a giant sock. Windsocks can be used as a basic guide to wind direction and speed or as decoration. It is commonly found at airports, especially on the runway, to indicate the wind direction and velocity, where this information can have a direct impact on pilot decisions. A windsock signals the direction of the wind. If the windsock is pointing north, then the direction of the wind is actually south. Wind direction is the opposite of the direction the windsock is pointed. Weather balloon. It measures conditions higher up in the atmosphere. It is also known as sounding balloon. It is a balloon that carries instruments aloft to send back information on atmospheric pressure, temperature, humidity, and wind speed by means of a small expendable measure device called radioson. Weather satellite. It is a type of satellite that is primarily used to monitor the weather and climate of the Earth. Satellites can be polar orbiting, covering the entire Earth asynchronously, or geostationary, hovering over the same spot on the equator. Satellite data help forecast the weather. The expert forecasters interpret the image and numerical weather. Prediction models assimilate observations.
Good afternoon, everyone. I'm going to discuss about the weather front and specifically the warm front. Let us find out first what is a front or a weather front. A weather front is a transition zone between two different air masses at the Earth's surface. Each air mass has unique temperature and humidity characteristics. When a front passes over an area, it means a change in the weather. Many fronts cause weather events such as rain, thunderstorms, gusty winds, and tornadoes. So what is the relationship between fronts and weather? A front is a weather system that is the boundary separating two different types of air. One type of air is usually denser than the other, with different temperatures and different levels of humidity. This clashing of air types causes weather, such as rain, snow, cold days, hot days, and windy days. There are four types of weather front. The four types of weather front are the cold front, warm front, stationary front, and an occluded front. Now you know what is a weather front and its four different types. I'm going to discuss one type of a weather front, which is the warm front. A warm front forms when a warm air mass pushes into a colder air mass shown in the image. Warm fronts often bring stormy weather as the warm air mass at the surface rises above the cold air mass, making clouds and storms. Warm fronts are move slowly than cold fronts because it is more difficult for the warm air to push the cold, dense air across the Earth's surface. Warm fronts often form on the east side of low-pressure systems where warmer air from the south is pushed north. On weather maps, the surface location of a warm front is represented by a solid red line with red filled in semicircles along it, like in the map on the right. The semicircles indicate the direction that the front is moving. They are on the side of the line where the front is moving. Notice on the map that temperatures at the ground level are colder in front of the front than behind it. You will often see high clouds like cirrus, cirrostratus, and middle clouds like altostratus ahead of a warm front. These clouds form in the warm air that is high above the cold air. As the front passes over an area, the clouds become lower and rain is likely. There can be thunderstorms around the warm front if the air is unstable. So, to sum it all up, let us understand the origin of the warm front. The origin of a warm front is caused by the tropical air meeting a colder polar air. With the warm front coming, the atmospheric pressure decreases while the temperature increases because of the warm air having a lower density. The warm front has a more extended slope than the cold front and thus leads to different types of clouds and amount of precipitation. The warm front moves slower than the cold front that sometimes lead to an occlusion. When a cold front catches up with a warm front and the energy of both fronts adds up, the warm air is then pushed up and a strong depression or a lower pressure forms just before.
Good day. Our topic for today is about cold front. Now, let's discover facts about it. A cold front forms when a cold air mass pushes into a warmer air mass. Cold fronts can produce dramatic changes in the weather. They move fast, up to twice as fast as a warm front. As a cold front moves into an area, the heavier cool air pushes under the lighter warm air, causing it to rise up into the troposphere. Lifted warm air ahead of the front produces cumulus or cumulonimbus clouds and thunderstorms. As a cold front passes, winds become gusty. The weather along it is violent. There is a sudden drop in temperature and also heavy rain, sometimes with hail, thunder, and lightning. Atmospheric pressure changes from falling to rising at the front. After a cold front moves through your area, you may notice that the temperature is cooler. The rain has stopped, and the cumulus clouds are replaced by stratus and stratocumulus clouds or clear skies. As for its symbol, you may notice that a cold front is represented by a solid blue line with filled-in triangles along it. The triangles are like arrowheads pointing in the direction that the front is moving. Here, temperatures at the ground level change from warm to cold as you cross the front line. And note that the air behind the front is cooler compared to the air ahead of it. This is Irene S. Chavez. That will be all. Thank you.
Apart from cold and warm front, there is this cold stationary front. In stationary front, there is a pair of air masses wherein neither of which is strong enough to replace the other. This type of front happens when two masses of air are pushing against each other, but neither is powerful enough to move the other, causing the cold and warm fronts to stop moving. That is why it is called stationary. Now we are done defining what is a stationary front. Let us proceed to its properties. So stationary fronts tend to remain essentially in the same area for an extended periods of time. Second, there is a noticeable temperature change, and a shift in wind direction is commonly observed when crossing from one side of the stationary front to the other, since it is a boundary. Third, the weather along the stationary front is often cloudy, and rain and snow often falls when there is a lot of water vapor in the warmer air mass, and especially if the front is in an area of low atmospheric pressure. Last property is that if one air mass enters the other, then it will change into either a cold or a warm front, and that stationary front will now be classified as moving. What is the symbol of stationary front? On a weather map, stationary front is represented as red and blue solid lines with alternating blue triangles and red semicircles. The blue triangles point towards the warmer air, while the red semicircles point towards the colder air. The last type of front is called occluded front. Occluded front is a composite front formed in the process of cyclogenesis, wherein a cold front overtakes a warm front. Consequently, the warm air is separated or occluded from the cyclone center at the surface and is forced to rise upwards. Let us discover the properties of occluded front. Occluded front usually forms near a mature low pressure area. Look at the map. So, occluded front ends at a low pressure area with a large L on the map and begins at the other end where the cold and warm fronts connect. There are two types of occlusion, the warm and the cold one. In cold occlusion, the air mass overtaking the warm front is cooler than the air ahead of the warm front and plows under both air masses. In warm occlusion, the air mass overtaking the warm front is not as cool as the cold air ahead of the warm front and rides over the colder air mass while lifting the warm air. Another property is that precipitation is often along this type of front from cumulonimbus or nimbus stratus cloud formations. As this front passes, the wind changes direction and the temperature either warms or cools. However, after this front passes, the sky is usually much clearer and the air is drier. What is the symbol of occluded front? Occluded front on a weather map is represented as a purple line with alternating triangles and semicircles. These alternating triangles and semicircles are pointing towards the direction of the movement of the front.